Press the bell icon on the YouTube app and never miss another update.
Polynomial function or simply polynomial. Listen here. Let us take n. N is a non-negative integer. Non-negative integer. Non-negative means what? Greater than or equals to 0. It is called non-negative. Means it is not negative. It is positive and maybe 0, just like that. Next. Let us take x is any real number. Function defined as capital R to R. It is defined as y is equal to f of x, that is equal to a0 plus a1x plus a2x square. a1x means x power 1 plus a3 x cubed. Let her tell me what will come. a4, a suffix 4, x to the power of 4 plus and so on plus an into x to the power of n. So this equation or function, that is y is equal to f of x, that is equal to a0 plus a1x plus a2x square plus a3x square x cubed a4 x to the power of 4 plus and so on plus an x to the power of n. It is called the polynomial function. Okay. N is what? N is non-negative integer. Here x is what? Any real number. Understand? Okay. Then what about a0, a1 and so on? a0 here a0, a1, a2 and so on, an are coefficients. It is called coefficients or constants. Understand? This is the simple definition. Okay. It's a domain. Its domain is equal to capital R. Its codomain also same. Domain equal to real number set and codomain is equal to real number set. Okay. We have to discuss here different kinds of polynomials. It is very essential. Okay. Number 1. Here f of x is equal to, already I said about the constant function. Right. F of x is equal to something constant. You can take any value k. F of x means what? Y is equal to. Simply y is equal to. So f of x equal to k. Actually k means k into 1. That is equal to k into 1 can be written as x power 0. Correct? X is any real number, finite number. It is also a polynomial. 1 minute. This is called degree of x. This is called degree. So therefore, a polynomial of degree 0 of degree 0. Thus every constant is a polynomial of degree 0. Understand? Next another example. For example, y is equal to ax plus b. Here x power 1. A comma b are a coefficient, b is constant. X is what? Real number. Already I said about X. X is the real number. This is called, it is also a polynomial of degree 1. Of degree 1 means here actually this can be written as a into x power 1 plus b into 1. Am I right? B is equal to b into 1. 3 is equal to 3 into 1. 5 is equal to 5 into 1. In the same sense, b is equal to b into 1. 1 is equal to, already I said 1 is equal to, we can write x power 0. Right. What is the degree of x? 0. Degree or exponent, we can say like that. Next, it is what? 1. What is the degree of x? 1. X. What is the degree of x? 1. So which one is the highest out of 0, 1? 1. So therefore, it is a polynomial of degree 1. Means what? The highest degree of the variable, actually x is called the variable, b is called the constant. This is once again, the highest degree of the variable x is 1. Itself is degree of the polynomial. You come here. I can give another definition. The highest degree of the variable in given polynomial is the degree of the polynomial. It is the basic. Okay, you come here. Next, 1 minute. Particularly, y is equal to ax plus b is called as linear equation. Linear means first degree. Right. Next, number 3. Y or f of x equal to, take another, ax square plus bx plus c. Ax square plus bx plus c. Here a comma b comma c are called the coefficients. Especially a comma b are the coefficients and c is the constant. Particularly a is the coefficient of x square, b is coefficient of x, c is the constant. Here subject to the condition a should not be equal to 0. Here also subject to the condition a should not be equal to 0. If a should not be equal to 0, then only it is called linear. If a is not equal to 0, in this case y is equal to f of x is equal to ax square plus bx plus c. Especially it is called actually it is called as a polynomial. It is a polynomial of degree. Tell me, how much is the degree of this function? 2. Why? Highest degree is 2. Of course, it is x power 1 and into x power 0. 0, 1, 2. Out of which one is highest number? 2. So therefore, already I said x is the variable. Here, x is called the variable. So x is variable. Which one is the highest degree? 2. The highest degree of the variable x is what? 2. Itself is the degree of the polynomial. This is 2. So therefore, particularly it is called as quadratic equation. Understand? Next, number 3. Y is equal to f of x, that is equal to, next, degree 3 we are taking a x cubed plus b x square plus c x plus D. Of course, A should not be equal to 0. A should not be equal to 0 means what? X cubed coefficient A should not be equal to 0. For example, sir, if A is equal to 0, then what will happen? For example, put A is equal to 0, then it will be 0, then it becomes a quadratic equation. Understand? That's why while we are defining a polynomial of degree 3, while we are writing degree 3, A should not be equals to 0. That's why I wrote A should not be equal to 0. A not equal to 0. This is called a polynomial. This is called a polynomial of degree. Tell me which one is the highest degree of the variable x? 3. So therefore this is 3. This is 3. Okay. Especially it is called as cubic equation. It is called as cubic equation. Cubic equation. Okay. Next number 4. Y is equal to f of x, that is equal to a x to the power of 4 plus b x cubed plus c x square plus d x plus e. Subject to the condition same, a should not be equal to 0 means x to the power of 4, the coefficient of x to the power of 4 is not equal to 0. So in this case it is called as a polynomial of degree 4. Particularly it is called as biquadratic equation. Bi means 2. Quadratic means under 2. 4. 2 plus 2. 4. Biquadratic equation. So therefore, similarly, we can establish a x to the power of 5, 6, 7 and so on like that. Okay. It is enough to know up to 4 maximum. Actually, up to 3 enough. Sometimes we are seeing x to the power of 4 expressions, equations, inequations also. Therefore, it is enough. So once again, every constant is a polynomial of degree 0, and this is the linear equation. Linear equation is a polynomial of degree 1. Quadratic equation is a polynomial of degree 2. Next, cubic equation is a polynomial of degree 3. Next, biquadratic equation is a polynomial of degree 4. Understand? Right. Rational function. It is a small definition. Rational function. Suppose f of x comma z of x be the polynomials of any order, then the fraction f of x divided by simple definition z of x, it is called rational function. Subject to the condition z of x should not be equal to 0. Already I said it. If g of x equal to 0, what will happen? In the denominator 0 is there, it is not defined or meaningless or undefined. So therefore, g of x not equal to 0. Then this form is called the rational function. Example, x plus 1, it is one polynomial, of course linear expression, divided by something x square plus 2x minus 6, just like that. X square minus 3x plus 1 divided by x cubed minus 6x plus 7, like that. So it is a polynomial of degree 2, it is also a polynomial of degree 3. So therefore it is in the form of f of x divided by z of x. So this is called the rational function. Synonym function. Spelling signum function. Important, very important. spelling as signum, S-I-G-N-U-M, signum function. But read as sinum function, G silent. Okay. It is defined as, for example, F from capital R to capital R. Okay. I said domain and codomain. This is the domain. This is the codomain. This is the codomain, comma. It is defined as very simple, +1, comma, if x is positive, any real number, positive real number, that is equal -1, comma, if x is negative, and that is equal to 0 if x is equal to 0. What does it mean? What does it mean? You can take any positive real number. It assumes that +1. Means for all x positive real number it is +1. For all x negative number it is defined as -1. For x equal to 0 it is 0. So it is called sinum function. So clearly here this is the domain. Okay. Domain means the values of x. Here domain is what? R. So we are putting capital R. We are putting capital R. Next, what is the output when function is a sinum function? Sinum means it is simply represented as a Zn of x. It is f of x. Understand? Sinum means simply represented as Zn of x. Zn of x. Output is what? Only the set of -1, +1, 0. This is the range. This is the range. R, y value. R, f of x value. R, output. It is what? Domain. Domain means values of x. The values of x, already I wrote here. Okay, I will write separately. Domain, the values of x are input like that. Okay, right. So therefore range, the set of, it contains 3 elements, -1, 1, 0. It is not singleton set. Okay, range, domain, or codomain, or. So therefore I will write here domain of a Zn function of x is capital R. First point. Second point, codomain is equal, see, capital R. Third point, range is equal the set of -1, 0, 1. Okay, order not necessary. This is the range. 1 minute. Graph. So graph is also important. Wherever necessity or essential or important, I will draw the graph. Understand? Right. Here, first draw the coordinate axis. Draw the coordinate axis. Coordinate axis. X-axis, y-axis, origin, right? For x positive means if we are starting with after 0, 0.000000000, it is also positive. Okay. Where is 1? For example, this is the point 1. Where is -1? At the same distance, -1. Okay. Okay, right, minus 1. Next, x positive means from here, this is 1, the point 1, understand? For x positive means just here, so this is the point 1. Next, for this point 1, for this point 1, just like that, and so on. It is going on just like that. Understand? That's why we are drawing like that. We are drawing like that. This is 1. Like that. Next, if x equal to 0, y equal to 0, means this is the point. X 0, y 0. Y, f of x means it is nothing but y. If x is negative, minus 1. Negative means this side. Actually, this is minus 1. It will be minus 2, minus 3, and so on up to minus infinity. So, suppose this is 1, it is origin, this is 2, this is 3, and so on like that. Okay. Next, minus 1 means suppose this is the point, minus 1, I will write here minus 1. So x negative. For example, minus 1, it is minus 1. For minus 0 point something also, it is minus 1. Therefore, it will be started like that. Hence, we can draw. Is it visible? We can draw like that. Will be like that. This is y dash axis. Okay, it is minus 1. Understand? Right. This is the graph of synonym function. This is y equal to f of x equal to s0 of x. S0 of x. Okay, it is defined as plus 1 if x is positive, minus 1 if x is negative, 0 if x is equal to 0. Just like that. This is the graph of synonym function. This is the definition. This is easy understanding for domain, codomain and range of the function synonym function. Clearly I wrote domain, codomain, range. Okay. Modulus function. This is the important lesson. Modulus function. Actually, a simple definition is f from capital R to capital R is defined as, is a function is defined as f of x is equal to mod. It is read as, just you draw two small vertical lines and between put x. Between them put x. This is the notation. F of x is equal to modulus of x, comma x already I said it belongs to R, is called as modulus function. Okay. Some practical definitions here. Actually, before that, we can open this definition before going to practical definitions or examples. It can be defined as plus x it is very important. If x is positive, minus x if x is negative, and it will take 0 if x equal to 0. This is the important one. Okay. Did you understand? No. That's why take some examples. Here, I will explain through the examples. I am asking some simple questions. Modulus of 0 is what? 1 minute. Modulus of 0 is what? Here, modulus of x is equal to 0 if x equal to 0. He said like that. If x equal to 0, f of x that is equal to 0. F of x means modulus of. So that means modulus of 0 is equal to 0. So therefore modulus of 0 is equal to 0. Modulus of 0 is equal to 0. Next, here you come here. What is modulus of 3? We don't know. For example, let x equal to 3. This is the procedure. Basic. X equal to 3. Is 3 positive number, negative number? Positive number. So therefore x is greater than 0. Correct. When x is greater than 0, then modulus of x, it is defined as plus x. Okay. So therefore modulus of x is what? 3. Therefore modulus of 3 is how much? Plus 3. Shall I show another example? Let x equal to root 2 positive value. Is it positive or negative? Positive. Therefore x is positive. When x is positive, modulus of x is what? Plus x. Put x equal to root 3. So modulus of root 2. Modulus of root 2 that is equal to plus x root 2. So therefore modulus of root 2 equal to root 2. Alright, we are getting the same. Modulus of 3 equal to 3. Modulus of root 2 equal to root 2. Modulus of 5 is equal to 5. Modulus of 7 is equal to 7. Modulus of 9 equal to 9. Modulus of root 3 is equal to root 3. Modulus of 100 is equal to 100. Modulus of 3 by 7 is equal to 3 by 7. Modulus of 5 by 9 is equal to 5 by 9. Okay. We understood, sir, for x equal to 0 and for x positive. Now explain when x is negative. Okay. Let us take some examples. X equal to minus 7. Let us take x equal to minus 7. 1 minute. Minus 7 means what? It is negative number. Correct? Correct. So x is negative. Therefore, x is negative. When x is negative, then according to definition, what is modulus of x? When x is negative, modulus of x means what does it mean? No confusion. Modulus of x is equal to plus x if x is positive, minus x if x is negative, that is equal to 0 if x is equal to 0, just like that. Okay, x is negative, you come here, x is negative case, so therefore it is minus x. Modulus of x equal to minus x. Now put x equal to minus 7. X is what? Minus 7 in our example. So modulus of, we are putting x equal to minus 7. Minus 7, that is equal to minus x is what? Minus 7. Did you understand? Did you understand? Once again, put x equal to minus 7. Okay, modulus is equal minus x is what? X minus 7. Minus into minus plus. So it is plus 7. Therefore, modulus of minus 7 is equal to 7. Of course, modulus of 7 is equal to 7. So modulus of minus 3 is what? Plus 3. Shall I show another example? Okay, I will take another example. X equal to, you tell me one negative value, minus 11. Minus 11. So it is negative number. Therefore, x is negative. So x negative means modulus of x equal to, according to definition, minus x. So modulus of minus 11, that is equal minus x minus 11. Don't forget it. Minus already is there. Okay, right? Minus x is what? X minus 11. Thus, minus into minus plus 11. Understand? Right. 1 minute. So, therefore, modulus of minus 11 is equal to 11. Modulus of minus 9 equal to 9. Modulus of minus 5 is equal to 5. And modulus of 5 is also equal to 5. Therefore, I will write few numbers or values. Modulus of minus 1, it is also equal to modulus of plus 1, that is equal to plus 1. Modulus of minus 2, it is also equal to modulus of 2, that is equal to 2. Modulus of 3 by 2, it is also equal to modulus of minus 3 by 2, that is equal to 3 by 2. Okay. Next, modulus of minus root 2, that is equal to modulus of root 2, that is equal to root 2. Just like that. I understood that modulus of any positive number or negative number, it is coming positive. Modulus of 0, it is 0. Positive means it is greater than 0. Is equal to 0 means is equal to 0. So therefore, you come here. Therefore, you can put either R plus positive real numbers. It is denoted by this capital R plus on the head, write plus. Negative real numbers. Its notation is capital R minus. Understand? Okay. So therefore, we can put any real number, but output will be greater than or equals to 0. Understand? Already I said in the intervals, if x is greater than or equals to k, means we can write x belongs to closed interval of k comma plus infinity. I don't like that. Understand? Okay. According to that is range is equal to closed interval of 0 comma infinity. Either you make a note. Plus infinity, for example, open interval of 2 comma 3, or another interval, closed interval 2 comma 3, that kind of, and open interval of 2 comma plus 3, and closed 2 open 3. This is the finite number of intervals, whether it is full open interval or full closed interval or half interval, it is out of question. Whenever we are getting infinity is not the number. That's why, for example, closed interval of 2 comma infinity. Wherever you are getting infinity, it should be in open interval, but not closed interval, because infinity is not a number. It is one concept beyond the real number. Understand? Right? Just like that. Okay. Similarly, minus infinity also. Minus infinity, we have to put in the open interval. Minus infinity to closed. We have to represent like that. If you are getting infinity everywhere, it should be kept in open interval. If you are getting minus infinity everywhere in mathematics, then you should keep in open interval. Or minus infinity or plus infinity, it should be kept in open intervals only, but not closed intervals. Closed stands for only finite numbers. 2 finite number, 3 finite number. infinity, it is not a finite number. Actually, it is not a number. It is a concept. Therefore, you should keep in open interval. Minus infinity, it is not a number. It is a concept. That's why put in open interval. Okay, right. Simultaneously, I will explain some few minute basic points meanwhile the lesson. Okay, don't worry about that. So this is the function y is equal to simply modulus of x. Now come to the graph. Now come to the graph. Graph of y is equal to modulus of x. So therefore this is x-axis, y-axis. Similarly, first we can make one table. X equal to 0, x equal to 1, 2, 3 like that, and negative side minus 1, minus 2, minus 3 like that. Okay, so first I will make the table here. So before drawing any graph, it is better to make the table, right? Just it is enough to take few values. This is x, this is y, whereas y is equal to modulus of x. Okay, first 0, next 1, next 2, next 3, okay, and so on like that. Negative side minus 1, minus 2, minus 3, and so on like that. X values. Already I said modulus of 0 is what? 0. 0. Modulus of 1 is what? 1. Modulus of 2, where x equal to 2, y equal to modulus of 2. Modulus of 2. Modulus of 3 is what? 3. Modulus of minus 1 is what? Already I said plus 1. Modulus of minus 2 is what? 2, 3, and so on like that. In y values, all are greater than or equal to 0. We are never getting the negative values. Remember, understand? What I am telling that modulus of x is always greater than or equal to 0 for all any real number. This is the most important definition or formula or concept. Okay. Now represent 0. X is what? 0. X is what? 0. Y is what? 0. X is what? 1. Y is what? 1. X is what? 2. Y is what? 2. 3. 3. Similarly here, minus 1, 1. Minus 1, 1. Minus 2, 2. Minus 3, 3. Like that and so on. So first we represent 0. 0 means, okay, this is origin. Next, this is 1. This is 2. This is 3. This is 4. And so on. Here also 1, 2, 3, 4, like that. Okay, negative side minus 1, minus 2, minus 3, minus 4, like that. It is minus infinity. This one is up to plus infinity. Here also minus 1, minus 2, minus 3, like that. Of course, this is y dash. Negative side, this is y. Okay. Now represent the points. 0, 0. First 0, 0. 0, 0 means x 0, y 0 means origin. Next 1, comma 1. 1, comma 1. 1. 1, comma 1. 1, comma 1. Here x equal to 1. Look on here. X on the x-axis 1. So put the scale. Where is y? Where is y? Here is y. So join, draw like that. Draw a rectangle like that. Understand? So this corner point is our required point. Just like that. Means what I am telling that? What I am telling that x equal to 1, y equal to 1. First with pencil draw like that. Y is equal to 1 and x equal to 1. So which one is point of intersection? This one is. So here represent a point in the graph like that. 1. Similarly, x equal to 2, y equal to 2. Y equal to 2. Y equal to 2. X equal to 2. Like that. Okay? Right. Just like that. So 2. 3, 3. 3, 3. Just like that. 3, 3. Similarly, x minus 1. Y is equal to 1. Means first I will join this one. 1 minute. by joining all such points in the graph, we are getting this kind of line or graph. So by joining the points will be like that. Understand? Okay, right. 1 1, where is 1 1? Just like 1 1, just like 2 2, just like 3 3, just like that. Next side, you come here. Minus 1 1, minus 1 1. The x minus 1, y is equal to 1. It is in the second quadrant. Okay, so by joining all the points, we are getting the graph. We are getting the graph will be like that. Understand? Just like we are getting V-shaped graph. Okay, we have to take some precaution in drawing that graph. For example, don't draw like that. It is wrong. It is not. Y is not equal to modulus of x. Understand? So take the precaution. Correct. Actually, it is 90 degrees. Correct half 45 degrees. So join like that. Here also, it is 90 degrees. So take diagonal. It is correct word. Diagonal means this is a square. So this is the diagonal. Draw diagonal like that. Here also draw diagonal like that. So it is making 45 degrees. It is also making 45 degrees. This is the precaution drawing the graph y is equal to f of x. Okay. So therefore, this is the graph y is equal to modulus of f of x. Okay. Particularly, this representing y is equal to x, and it is representing y is equal to minus x. Remember, this is in the second quadrant. It is called second quadrant. First quadrant, second quadrant, third quadrant, fourth quadrant. Later, I will explain very clearly in the trigonometry topic. Okay. So it is the first quadrant. Okay. It is the first quadrant denoted by Q1. It is the second quadrant denoted by Q2. So in the first quadrant, so that it is making 45 degrees with x-axis will be like that. Next, it is also making 45 degrees with y-axis or x-axis. So it is denoted by y is equal to minus x. This is y is equal to x. All together, it will be in the shape of V, and it is called y is equal to modulus of x. This is all about modulus function. First, you have to read that examples, practical meanings. Understand? 1 minute. Already I showed, na? So therefore, once again, I wish to write here its domain and codomain range. So therefore, the function is equal to y is equal to modulus of course it is f of x. This is the function. Next, first point, domain. Domain is equal to capital R. Number 2, codomain is equal to capital R. Number 3, range. Number 3, range is equal to closed interval of 0, infinity. Of course, it is subset of real number. Understand? Okay. Therefore, range is subset of, or means codomain. Here, range is subset of, means proper subset of codomain. Codomain means codomain is a superset. Range is subset, means small set. Okay, right.